All right, welcome again. Welcome again to Good Choices. Oops, so my microphone's kind of bad. I'll try to fix that. Okay, mic check 1 2 1 2. I don't know. It's kind of being difficult, but anyways, this is going to be the Automate Your Network series. As I've said multiple times, probably usually start most videos with this. It's really hard to know what is a good choice and what is not. Um, I feel like learning the fundamentals is always going to be a good choice. So I would like to do more of that at some point. I'm so far along in this book that I think finishing it is a good idea. I also think there's fundamentals in the LPIC that are touched on that are important, but I do want to start another series soon where it's about building T-shaped engineers. Um, and so stay tuned later for a new series that I can feel really good about doing, because I'll be honest, the series I've been doing, I just feel like it's that situation where, like, no matter what you do, it's wrong, and by the time you finish doing it, like, everything's gonna change. It's like, you're just learning about, like, fickle here and now things that are the hot latest news. It's like you're in the fashion industry. You know, really what you want to be is in textiles or whatever. So, like, it's never gonna. You want to own a ethical uh, clothing factory. So you need to know the math and science and all that. So hopefully I can pivot to that in some way. But in the meantime, I want to keep going on this book here. It's just been kind of the fun part. So we're gonna start chapter 6. Yeah, I think that's been one of the hardest things in my career so far. It's just, it feels like no matter what you do, you didn't do it right. And, like, if you would have done the thing that presumably is right, then the thing you pivoted away from to do that thing is now suddenly the thing that is right. And it's like, because I'm in a, yeah. And the other thing is, like, it's so hard to talk about, like, what you did, because, like, I mean, it's like, for example, this book, the 5 chapters, like, you know, it, I don't know. I just find it really hard to, um, well, I mean, the thing is, and this is off topic. It's just like when you're applying to, like, hundreds and hundreds and hundreds of jobs, like, and not getting one for, like, a few months. It's like it's to a point where it's like there's just so much information out there. It's hard to remember, like, what you're even talking about, and it's just, yeah, it's just. I mean, when has the world ever been easy? To be honest, it's like this is what it means to be a human, is just to be in constant pain and suffering. So let's, speaking of which, let's continue reading this book with chapter 6, network reconnaissance. So we got a quote here for, oh my god, what? Okay, so Shades of Grey. I've heard of 50 Shades of Grey. I've never heard of this. So let's see what this is. Oops, we're going to Twitter now. We're not doing the thing I want to do. I have to hit a Control C. So Shades of Grey. Oh, this actually, I'd be interested in reading this. So it's a dystopian novel, and it's the first in the Shades of Grey series. I guess this isn't 50 Shades of Grey. Yeah, so this is like a fantasy science fiction book. Yeah, I'd actually be pretty interested in reading this. That'd be fun. Something I could do on this channel too is to read like science fiction books, fantasy science fiction books. Yeah, this looks wonderful. I love that. I love that when like, because if you're from the United States, like so there's something called the availability not virus, so might as well be that, but it's a availability bias. So it's like the human tendency to rely on information that comes readily to mind. It's like, so it's like, for me, like when I think of books, because I don't really, I do a lot of technical things, but I don't really like read stuff like this for fun. It's like I can only really think of like 50 Shades of Grey and like the idea of a dystopian science fiction fantasy novel. Like, it just doesn't really come to mind very easily. And I honestly feel like reading this book would like really enrich my life. But anyways, moving on. So here's a quote from it. Okay, this is the wisdom. First, time spent on reconnaissance is never wasted. That's true in my opinion. Second, most anything can be improved with the addition of bacon, except for risk of colon cancer, I think. But when it comes to the taste of food, maybe they do have a argument there. But at what cost? All right, so gathering information about network devices and logical topology are the next steps to network automation. The Ansible / Cisco iOS_facts module is used to gather platform information, while the iOS_command module is used to run commands and gather input. These are these are foundational steps to build upon. So here's an example of a enterprise network topology. So and let's see how this compares to the one I have in my lab. Okay, so it looks like mine. So this is like what a core is. Like, you might be thinking like, oh, why not just hook the distribution layer up to the hub, and why even have that core? And it's like, well, that's because you can build off of that core. So yeah, you can have more distribution layers off of that core. So yeah, like here's an example. So off the core, you can have distribution devices that go out to your WAN. You can have distribution devices that go out to your data center. Ones that go out to just the public internet. So these are behind firewalls. And then these go out to your like office buildings. So here's a more simplified version of it. And we can see the wiring. So let's take a look at how close or far mine is from that. So mine's kind of close. I only have one device in my core. So, this isn't that great of a enterprise network. It's just meant to be simplified. So it's not too badly simplified. If I need more in my core, I do have to add interfaces to that device. But anyways, yeah, let's do it. Let's start automating the network. So this is exciting. I might change this topology at some point. It's just not that great of a topology. And the other thing is like you wouldn't have the WAN. This WAN is like, what is it connecting to? Oh, it's connecting to the core, so that's fine. Okay, so the WAN is not that bad, but you wouldn't have these like single points of failure. So you definitely would have an extra device in the core, and then you definitely have two devices in the WAN, and then you'd have the connection to the WAN being redundant as well. So like, yeah, this is a much better network than the one I've got. And I'm kind of interested to I kind of want to change it. Now we can see the data center I got like pretty well, but the data center, and this is kind of interesting that the data center isn't connecting to this WAN cloud here. I wonder if that's an error. Let me try something really interesting. So let's copy this image. You know what? Let's screen scrape this image. I love how like the AI, like you can say like, who are you, and or like tell me your opinion, and it'll be like, oh, I don't have opinions, I'm just an AI. But then you say like, here's this complicated thing, tell me what you think of it, and it'll be like, well, I think of it. It's like you kind of can catch it and like have it like say things that it's not allowed to say. But there should be a plugin here um, for like a graphic. I'm pretty sure I have it. So that's to build it. I need one that can read graphics. So this is for OCR. Let's go to the plugin store and look for screenshots. Okay, so that's taking screenshots. So let's do image. All right. See, I just want to get the opinion. Current files like image converter app. I want it to analyze. I want to be able to put an image into the prompt. But I think the only way that it can handle that is by doing a extraction of the words in the image. I don't think it can look at the actual image itself. And this data analysis now why can't I change it back? Oh, here we go. Like this data analysis, I can give it, I don't think I can give it let me see. Let me save it. So we're going to save it to downloads. And that's going to be enterprise network. Internet. All right, and then let's try. Now I can close this window. So let's try attaching the file. Okay, let's see what it can do with that.
I see that you have uploaded a file named end_net. PNG. How can I assist you with it?
So, analyze. Oh, how do you spell analyze? ANALAYZE. Okay. Thank goodness for spell check. There's just too many words out there. I can't spell them all. All right, so I see you have uploaded this file. How can I assist with it? So analyze the network diagram. Give expert opinions about the architecture. Suggest improvements. Point out strengths and weaknesses.
To assist. You better. I will first open and display the uploaded network diagram.
Good job.
Let's proceed with this.
So this is cool because you can see it's doing it in Python. Python is
Thank
a
you for your
great,
patience.
great
Now that we
language.
have the network diagram displayed, I will proceed to analyze it based on general principles of network design and architecture.
I love this.
Analysis strength segmentation. VLAN segmentation. The use of VLANs helps in segmenting the network, which can aid in reducing broadcast domains and improving network efficiency. DMZ. The inclusion of a DMZ, demilitarized zone, for hosting public services like web servers is a good practice for security. Redundancy. Dual firewalls. The deployment of dual firewalls can ensure high availability and fault tolerance. Security. Firewalls. The presence of firewalls helps in protecting the internal network from external threats. VPN for remote access. The VPN, virtual private network server, can provide secure remote access to the internal network. Weaknesses: single point of failure. Single ISP. Having a single ISP, internet service provider, can be a potential single point of failure. In case the ISP faces downtime, the entire network will lose internet connectivity. Network complexity. Multiple VLANs. While VLANs offer segmentation benefits, they can also increase the network complexity, requiring more sophisticated management and configuration. Improvements: ISP redundancy. Additional ISP. Consider adding another ISP to avoid a single point of failure and ensure uninterrupted internet connectivity. Monitoring and management. Network monitoring tools. Implement network monitoring tools to keep an eye on the network's performance and quickly identify issues. Security enhancements. Intrusion detection prevention system, IDS, IPS. Consider integrating an IDS, IPS system to enhance security by identifying and preventing known and unknown threats.
Okay, so this is great. We'll go over it in more detail. The first thing I want to do, though, is test that it's actually reading the diagram. So I'm going to ask it a pretty simple question to try to check its knowledge. I'm going to say, at what layer of the network is the WAN cloud image shown? And I will be impressed if it gets this right.
In the network diagram, the WAN cloud image typically represents the wide area network, WAN, which encompasses large geographic areas, potentially worldwide. It is generally used to represent the internet or a large carrier network that is outside of global.
So yeah, it's just giving generic. It's not. I don't think it's actually reading the diagram, but that's not too bad. So I'm gonna ask it again. I'm gonna say no. What I mean is, in the uploaded diagram, there is a picture of a cloud with the word WAN written inside. Do you see it? At what layer, as shown in, at what layer of the diagram, as is shown on the right hand side, does this picture of a cloud belong?
The misunderstanding. In order to properly answer your question, I need to closely inspect the diagram to identify the different layers and locate the WAN cloud within them. Let me proceed with this. Thank you for your patience.
Cool.
I can see the diagram more clearly now. Please guide me to identify the layer where the WAN cloud image is located, as indicated on the right-hand side of the diagram. Let me know the details of the labeling of the layers as presented in the diagram.
So yeah, x equals 100. Y. This is cool. I love this. Yeah. So x. So it's right there. I love this. I'm in heaven right now.
Thank you for providing the coordinates.
Yeah, it's
The
right
red
there.
marker on the diagram indicates the point with coordinates x equals 100, y equals 500. To identify the layer where the WAN cloud image is located, I would appreciate it if you could describe what is written or depicted in the layers around the marked point. If possible, please provide a range for Y coordinates that corresponds to each layer mentioned in the diagram. This will help in accurately identifying the specific layer where the WAN cloud is situated.
Okay, so the area of the diagram where the layers are written is the whole column above x equals 100. I meant to say above instead of about, but hopefully it'll get that. Yeah.
Thanks.
Oh, that's
You for
so
pointing that out.
cool.
The red dashed line represents the column where the layers are detailed at x equals 500, x equals 500, x equals 500.
It can tell me.
To
That's so
identify the
cool.
specific layer where the WAN cloud is situated, I will extract the text content from that column.
That's so cool.
Let me proceed with this approach. B. OCR, optical
Look
character
at
recognition,
that.
extraction wasn't very clear, but it seems to have identified several layers. The extracted text mentions phrases which resemble layer repeated several times, albeit with some character recognition errors. To properly identify the layer where the WAN cloud is located, we can try to infer from the partial extracted text and the location
That's
of the WAN cloud in the
so
diagram
cool.
around y equals 500. Given the unclear OCR result, I would appreciate if you could provide the correct labels for the layers as shown in the diagram. Once I have the correct labels, I will be able to identify which layer the WAN cloud falls under based on its y coordinate.
Yeah. So I'll do this. So I'll do y equals 100. Axis. This is so cool. Y equals 150. Distribution layer. Y equals, and what is that, like 275? So y equals about 375. This is so cool. And then y equals 475.
Thank you for providing the details of the layers and their corresponding y coordinates. Given that the WAN cloud is located at y equals 500, which is beyond y equals 475, the y coordinate for the access layer, it seems that the WAN cloud is situated below the access layer depicted at the bottom part of the diagram. Based on typical network hierarchical design, this area might represent the external network or the internet connectivity layer that connects the enterprise network to the wider internet, WAN. So, to conclude, the WAN cloud image is located in the area representing connectivity to external networks, which is beyond the access layer at the bottom part of the diagram.
That's so cool.
It doesn't fall within any of the specified layers, access, distribution, core, based on the y coordinates you provided, but is closely associated with the bottom access layer.
That is so cool. And like, you know, the AI is going to be able to do this on its own real soon. That is so cool. My mind is like literally blown away right now. So let's ask it about the okay, great. So I have a question about the data center. Okay, great. So I have a question. So I now have a question about the data center from x equals 200 through 300 and y equals 500 through 350. Okay, great. So now I have a question about the data center. Why is it connecting into the core layer shown at y equals 300 through 200? Doesn't it make more sense for it to be connecting to the WAN?
Connecting the Data center directly to the core layer rather than to the WAN has both advantages and disadvantages, and whether it makes more sense can depend on the specific requirements and circumstances of the network.
Okay.
Here, I'll outline both the potential benefits and drawbacks of this configuration. Benefits of connecting to the core layer: high-speed access. Connecting the data center directly to the core layer ensures high-speed access to the data center resources for devices within the network.
Well, let's talk
The core
about
layer is
this.
designed.
Well, let's hear it out.
If the primary users of the data center are internal to the organization, the current setup is sensible. If the data center needs to be accessed frequently from external networks and rapid internal access is less of a priority, then connecting it to the WAN might be a more sensible choice. However, I would generally recommend against connecting a data center directly to the WAN without substantial security measures in place, given the increased vulnerability to external threats that this would entail.
So tell me about. So then tell me about the technical limitations. Is there a distance limit that the data center can be from the core layer? And does this mean that you can't use a pre-existing colo? You have to build out your entire data center from nothing. Tell me about the costs associated with this and the limitations, especially when it comes to how far your data center can be and the maximum size of your data center. Tell me about other ways to design this, for example, using a cloud solution. This is so cool.
Absolutely. Let's delve into the various aspects of connecting a data center to the core layer, including the technical limitations, cost implications, and alternative solutions. Technical limitations: distance limitations. When connecting a data center to a core layer, the physical distance between them can indeed be a limiting factor.
Yes.
The limitations can stem from latency. The greater the distance, the higher the latency. This can be a significant factor if your data center hosts real-time applications or services requiring low latency. Cable types and data transmission rates. Different types of cables, e.g., copper, fiber optic, have varying maximum distances for optimal performance. For instance, while copper cables are limited to shorter distances, up to 100 meters for Ethernet cables, fiber optic cables can facilitate connections over tens of kilometers without significant degradation in signal quality. Maximum size of the data center. The maximum size of your data center would primarily be influenced by cooling and power requirements. Larger data centers require substantial cooling and power infrastructure, increasing complexity and costs. Network infrastructure. A larger data center requires a more complex network infrastructure involving more switches, routers, and other network devices, and consequently a more extensive network management overhead. Cost implications: infrastructure build-out. Building out a new data center from scratch can be incredibly costly, involving significant capital expenditure on land, buildings, and infrastructure, not to mention ongoing operational costs. Connectivity. Establishing high-speed, low-latency connections over long distances can be expensive, especially if it involves laying new cables over substantial distances.
Yeah.
Alternative solutions. Colocation. Using a colocation facility, colo, can be a good alternative to building a new data center, allowing you to leverage existing infrastructure. Colos already have the necessary infrastructure in place, potentially saving you substantial costs.
Would the colo, if you went with a colo, would it... What about... Oh, let me read this. So here's some alternative solutions to the diagram. And let me bring the diagram back up to make it easier to talk about. Okay, so here's the diagram here. Now you would have the way what we're talking about here is this data center. I think this is like this is where, like, you know, you like you can replace this with the cloud. But you have to, I think you have to then access it through your WAN, or you could access it through the internet. But like, I want to learn more about this. So here's an alternative solution. And what we're talking about when we're talking about an alternative solution, we're talking about an alternative to this data center here and connecting it into the cloud like that. So one alternative solution is to have a co-location. So using a co-location facility or colo can be a good alternative to building a new data center, allowing you to leverage existing infrastructure. Colos already have the necessary infrastructure and safe, potentially saving you substantial costs. Expand easily. Colos can often allow for easier expansion compared to a self-owned data center, providing flexibility as your needs change. So that's what you could do. And I do have a question about the colo. Let me just type it here as I'm going. So about the co-location alternative solution, if you went with this, could you still connect to the core layer, or would you need to connect the colo to the WAN or the internet? Same question for the cloud solution. Okay, so I'm going to read about cloud solutions now. So opting for a cloud solution, either entirely or in a hybrid configuration with an existing data center. Oh, that's cool. So you can also do a cloud selection where, like, let's say we have the data center, but we want to expand it. We want to add some more end devices. Now you can connect up to a cloud solution, but I'm not sure how to do that. So let's figure it out. But you can get some advantages from that. Cost efficiency, so substantial economies of scale, potentially saving you money compared to building and operating your own data center. So yeah, we could imagine, like, with all the cooling and power requirements, we need to double, triple, 10x this data center. That's going to cost a lot of money, and it might be worth it just to use somebody else's data center. So scalability, cloud solutions can be easily scaled up or down. So they have these massive data centers, and you're just paying for a piece of the pie that you can easily expand at any time. And then global reach. Major cloud providers have data centers globally, allowing you to host services closer to end users worldwide, reducing latency and improving performance. Conclusion while connecting a data center directly to the core layer can offer performance and security benefits. It does come with some substantial potential. Yeah, so I think when you leverage the cloud and colo solutions, you can't connect it directly to the data center. But let's find out.
When using a call, vacation facility, or cloud solution, you have various options for connecting them back to your corporate network.
Okay.
The connection can be established either through the core layer or directly to the WAN internet. Let's explore these options for both colocation and cloud solutions. Colocation facility connecting to the core layer direct fiber connection. If the colocation facility is geographically close, you can establish a direct fiber connection to your core layer, ensuring high-speed, low-latency connectivity. MPLS, multi-protocol label switching. For more distant colocation facilities, an MPLS connection can be used to establish a virtual private network, VPN, directly to your core layer.
Yeah.
Connecting to the WAN internet VPN over the internet. Establish a secure VPN connection over the public internet to connect your colocation facility to your corporate network. Direct internet access. The colocation facility can also be given direct access to the internet, potentially with a VPN back to your corporate network for secure communications.
Right.
Cloud solutions connecting to the core layer direct connect or equivalent services. Many cloud providers offer direct connect services that allow you to establish a private connection from the cloud to your core layer, bypassing the public internet for more secure, consistent, and high-speed connectivity. VPN. Similar to the colocation scenario, a VPN can be used to securely connect your cloud environment to your core layer over the internet.
Yeah.
Connecting to the WAN internet VPN. You can also connect your cloud environment to your corporate network over the public internet using a VPN for secure communications. Public internet. Cloud services can also be accessed directly over the public internet, potentially with security measures such as encryption to protect sensitive data.
This is cool.
Conclusion: both colocation and cloud.
All right, so I have one more question for it, and then I want to move on. I want to go back and read something, and then I think I am going to update my topology in my lab. Let me do another mic check. Looks good. So let's talk about the colocation facility connection to the core layer using MPLS, also known as multi-protocol label switching. If you were to do this, how could it be that you establish a virtual private network or VPN directly to your core layer? Wouldn't the actual physical links need to come in through the WAN, which is hooked up to the distribution layer? I don't understand how you can have a unique physical link connecting to your core layer if you want your connection to be through MPLS. What is the difference between an MPLS connection and a direct fiber connection?
You bring
Yeah.
up an important point, and I understand where the confusion might be coming from. Let's delve into the specifics of MPLS connections and how they can be implemented in the context of connecting a colocation facility to your core layer. MPLS, multi-protocol label switching, connection. How it works. MPLS operates at a layer that is between the data link layer, layer 2, and the network layer, layer 3, in the OSI model. It essentially directs data from one network node to the next based on short path labels rather than long network addresses, thus avoiding complex lookups and routing table.
Yeah.
Implementation and connecting to the core layer. When we talk about establishing a direct connection to the core layer through MPLS, what we generally mean is that the MPLS service is logically terminating at the core layer. The physical connection might indeed first enter through the WAN and pass through other network layers before reaching the core. However, from a logical perspective, this MPLS circuit is directly reaching the core layer, allowing for a more efficient, secure, and high-performance connection
they're
than
talking
routing
about
traffic through the
logical
public internet.
connections. But it
Direct
will
fiber
come
connection.
through
How it works. A direct fiber connection involves laying a physical fiber optic cable between the colocation facility and your core layer. This cable is dedicated to your use and facilitates a direct, high-speed connection between these 2 points. Implementation and connecting to the core layer. Just like with the MPLS connection, the physical fiber link will indeed initially connect to the equipment at the outermost layer, like router in the WAN environment, and then be routed internally to reach the core layer. However, because this is a direct link, it can offer lower latencies and higher throughput compared to an MPLS link that might traverse a provider's MPLS cloud and potentially take less direct path. Comparing MPLS and direct fiber connections cost. MPLS, generally less costly than establishing a direct fiber link, especially over long distances. Direct fiber can be quite expensive, particularly for long distance connections, due to the cost of laying and maintaining a dedicated fiber line. Performance. MPLS offers good performance but potentially slightly higher latencies compared to a direct fiber link, depending on the specific implementation and the provider's network. Direct fiber typically offers the best possible performance with the lowest latencies and
Okay, I have one more question. Is MPLS considered out of date? Is there a more modern technology?
as of my last
Okay.
update in September 2021, MPLS is not necessarily considered outdated. It is still widely used in enterprise networks and by service providers due to
Yeah, this is what I mean. Is like SD-WAN is what's
IPsec
not out
VPN
of
over
date.
broadband internet. Many organizations are also looking at IPsec VPNs over broadband internet connections as a more cost-effective alternative to MPLS. Cost-effective. Leveraging existing broadband internet connections can be significantly cheaper than MPLS. Ease of setup.
Like SD-WAN is like, I do think, this is 2021. I do think in 2023 and beyond, MPLS is going to be going the way of like frame relay, and it's all SD-WAN. Like, this is why I'm having trouble passing the Encore. I've taken it like multiple times and I haven't passed it, because like everything is different. It's all about SD-WAN. It's like half of the Encore. Here, let's do this. Let's start a new chat. So, what is the ENCOR Cisco exam, and how is it different from the traditional Cisco exam before there were changes to the curriculums? Please show me a difference between the curriculums of the Cisco exam before the ENCOR was introduced and after.
The NCORE, Implementing and Operating Cisco Enterprise Network Core Technologies exam, is one of the exams introduced by Cisco as part of its revamped certification program that started in 2020.
Yes.
Before we delve into the differences, let's briefly discuss what the NCORE exam entails. NCORE Cisco exam. The NCORE exam, code 350401, is a foundational exam for several certifications including CCNP Enterprise, CCIE Enterprise Infrastructure, CCIE Enterprise Wireless. The exam covers a broad range of fundamental topics for enterprise networking, including dual stack, IPv4 and IPv6, architecture, virtualization, infrastructure, network assurance, security, and automation. Differences in curriculums before NCORE introduction. Before the introduction of the NCORE exam, Cisco's certification structure was more fragmented with several different tracks for various specializations, including CCNP Routing and Switching Route 300-101, Advanced IP Addressing, Routing and Enterprise Network Switch 300-115, Planning, Configuring, and Verifying Complex LAN Switching Solutions TSHOOT 300-135. Troubleshooting and maintaining IP networks. CCNF Wireless Y Design, WIDEPLOY, WITSHOOT, and WiSecure were part of this track with focus on various aspects of wireless networks. After NCORE introduction, with the introduction of the NCORE exam, Cisco consolidated several of those tracks into a more unified certification path. The new curriculum is designed to be more integrated, focusing on both the core technologies and candidates' area of focus. Here's the breakdown. CCNP Enterprise Core Exam, NCORE 35401. This exam focuses on core enterprise technology.
All right, I'll be back. I need to take a quick break. All right, I'm back. Let's hit that again. Let's just have it read the whole thing.
The NCORE, Implementing and Operating Cisco Enterprise Network Core Technologies exam, is one of the exams introduced by Cisco as part of its revamped certification program that started in 2020. Before we delve into the differences, let's briefly discuss what the NCORE exam entails. NCORE Cisco exam. The NCORE exam, code 350401, is a foundational exam for several certifications including CCNP Enterprise, CCIE Enterprise Infrastructure, CCIE Enterprise Wireless. The exam covers a broad range of fundamental topics for enterprise networking, including dual stack, IPv4 and IPv6, architecture, virtualization, infrastructure, network assurance, security, and automation. Differences in curriculums before NCORE introduction. Before the introduction of the NCORE exam, Cisco's certification structure was more fragmented with several different tracks for various specializations, including CCNP routing and switching route, 300-101, advanced IP addressing, routing and enterprise network switch, 300-115, planning, configuring, and verifying complex LAN switching solutions, TSHOOD, 300-135, troubleshooting and maintaining IP networks, CCNF wireless Y-Design, WIDEPLOY, WITSHOOD, and WiseGear were part of this track with focus on various aspects of wireless networks. After NCORE introduction, with the introduction of the NCORE exam, Cisco consolidated several of those tracks into a more unified certification path. The new curriculum is designed to be more integrated, focusing on both the core technologies and candidates' area of focus. Here's the breakdown. CCNP Enterprise Core Exam. NCORE 35401. This exam focuses on core enterprise technologies. Concentration exams. Choose 1. ENARSI. 300-410. Advanced Routing and Services ENSL. 300-420. Designing Cisco Enterprise Network Channels. 300-425. Designing Cisco Enterprise Wireless Network Channels. 300-430. Implementing Cisco Enterprise Wireless Network Sonato. 300-435. Automating Cisco Enterprise Solutions. Comparison depth versus breadth. Before the NCORE introduction, candidates had to delve deep into specific tracks, focusing extensively on specific topics. The NCORE exam, on the other hand, covers a broader range of topics but at a more foundational level. Specialization versus integration. The previous certification path had a strong focus on specialization with separate tracks for routing and switching, wireless, etc. The NCORE curriculum integrates these tracks, providing a more holistic understanding of enterprise network technologies. Modern technologies. The NCORE curriculum introduces more modern network technologies, including automation and programmability, which were not as prominently featured in the older curriculums. Flexibility. The new structure offers more flexibility, allowing candidates to choose from a variety of concentration exams to tailor their certification path to their career goals and interests. Conclusion. In conclusion, the shift to the NCORE-based curriculum represents a modernization of the Cisco certification path, with a more integrated approach to learning and a greater emphasis on current technologies. It caters to the evolving landscape of network technologies and the skills required for modern network professionals.
Yeah, so here's why I keep failing the Encore, because first of all, it's not. So see, like, I had the CCNP, and like to recert my CCNP, I just needed to get my Encore. But the Encore, because I thought the Encore was like, the direct equivalent of like the CCNP, and then like to get the CCNP, you would pass the Encore, and then you would pass like one of these concentration exams. But the Encore is not just a direct equivalent to the CCNP. It's more of a direct equivalent to the CCIE written. So like it's going to have much more advanced, all the SD-WAN stuff that really wasn't on the CCNP because it didn't really exist is not going to be on there. And then the wireless wasn't that big of a part of the CCNP. I think there was some, but it wasn't huge. So yeah, that's why. And then it looks like it's like all this stuff is new, and that's why I keep failing it. But the good news is once I get it, then I can pick one or more concentration exams. And it looks like there's some good things. There's an automation concentration exam, which looks great. There's a there's two wireless ones which look good, so it's hopefully I do okay on it. Okay, so that's kind of off track. Okay, so I guess I'm feeling good about this. Let's go back and look at the main. So let's look at the analysis of this. So we've got some strengths here. So we've got VLAN segmentation, inclusion of a demilitarized zone. See, the thing is, it doesn't have that. It's just saying like what our general practice is. Oh, it's saying there are dual firewalls. There are firewalls, so I guess it is kind of no, it's just giving general advice, but it's giving general advice, which is like pretty good. Yeah. So you know what, I think I'm gonna take this time now and kind of revamp my lab. So let's do that. So we've got the image here. So let's build out the let's take away the management for now. I don't want to delete 2. I just want to delete 1. You have to be careful about that in GNS. It's really easy to accidentally select more than one device. You see now 2 devices are selected. So if you do that, then it'll try to apply whatever change you're intending to apply to one device. It'll try to apply that to 2 devices. So you got to be careful about that. Let's move the WAN up to the top. So in order to do that, I guess we got to move everything down to the bottom. All right, and then we'll move the let's no, this looks good. Okay. Oh man, this is tricky. And I can't do a control Z on it. Let's just keep moving. Let's move this up a layer. Okay, and then move this. Oh, this is so frustrating. Oh, and I can't control Z. We'll just do it like this, and then we'll just move each individual piece up. There we go. That looks like a much better network to me. Now the thing is, our WAN doesn't connect to the data center, so we need to remove these connections here. Let's do that. Okay, so here's our WAN. It's just kind of out there for now. So the first thing we need is another core device. So let's duplicate this. There we go, and then we'll call it yeah. So this is called core. We can change this to core 1 and then call it core 2. So we click this and we go to change host name. We'll call it core 01 because they're all like that. Let's keep the syntax. Change the host name on here to core 02. And hopefully they have different MAC addresses. I think they do. So we can kind of stray from the book a little bit. If the book's got a different, more simplified version of this, that's okay. We can use a more advanced one. Let's do it up to double the adapters. So let's do it to 8. Let me ask this. What is the number of ports that would be typically found on the core layer in a network diagram like this? Tell me specific things about the ports, such as if they are XFP or SFP, and whether they are fiber or copper, and the link speeds that they typically are. Tell me about the hardware specifications and physical details.
In a core layer of a large enterprise network, you would typically find high-capacity, high-speed routers and switches designed to handle substantial amounts of data traffic efficiently.
Yes.
The exact number of ports can vary significantly depending on the specific needs of the network. Let's discuss some typical characteristics. Number of ports. High-end core switches often come with a large number of ports, ranging from a few dozen to several hundred. However, in a core layer, it is common to find switches with 48 ports, common in many enterprise-level core switches.
48.
96 ports or more, for very high-capacity environments. Types of ports: SFP, small form factor pluggable, SFP. Supports speeds up to 1 gigabit per second.
Okay,
Can
we can
accommodate
do
both
that.
fiber and copper connections. SFP Plus, an extension of SFP, supporting speeds up to 10 gigabits per second, commonly used for fiber connections.
Yeah.
XFP, 10 gigabit small form factor pluggable, XFP. Primarily used for 10 gigabits per second connections and generally supports fiber connections. QSFP, Quad Small Form Factor Pluggable, QSFP Plus. Supports speeds up to 40 gigabits per second, often used in very high-speed environments. QSFP 28. Can support speeds up to 100 gigabits per second. Connection type fiber. Fiber connections are generally preferred at the core layer due to their high speed capacity and lower latency compared to copper connections.
Yes.
Common types include single mode and multi-mode fiber. Copper. Less common at the core layer due to its limitations on speed and distance.
Yes.
However, they might still be used for connections within a data center environment where distances are short. Link speeds at the core layer. High link speeds are essential to handle the substantial data throughput. Common speeds include 10 gigabits per second, a standard speed for many enterprise networks. 40 gigabits per second, increasingly common in high capacity environments. 100 gigabits per second, used in environments requiring very high speed connections such as large data centers. Hardware specifications. Core routers and switches come with a variety of features designed to support high speed, high capacity environments. High backplane capacity, to support the high data throughput. Advanced coast features, to manage data traffic effectively and ensure high performance for critical applications. Redundancy features, including power supply redundancy and link aggregation to ensure high availability. Physical details. Form factor. Core switches are often rack-mounted, with standard form factors including 1U, 2U, or larger for high-capacity switches. Cooling. High-capacity switches require effective cooling solutions to manage heat generation. Power. High-capacity switches require substantial power, with features like redundant power supplies to ensure reliability. Conclusion. In core layer, you would find high-capacity, high-speed routers and switches equipped with a large number of ports, supporting high-speed fiber connections using SFP+, XFP, or QSFP transceivers, among others, to ensure high performance and reliability in a large enterprise network. It is essential to choose hardware that matches the specific requirements of your network, considering factors like the expected data throughput and the need for features like redundancy and advanced coast features.
All right, so that was pretty interesting. This is like more what I'm used to seeing too. It's so nice to have like a sanity check because it's like, I don't know. There's this. It's sometimes it feels like my experience is like, I don't know, like not relevant or like just like a curveball thing, and it's not like widely applicable, and it's like sometimes it's like, am I crazy for believing that a QSFP 28 is real? It's like, no, I'm not. So okay, so there we go. Okay, so let me do this. Okay, great. Please redraw the diagram and print it out with the finer details, such as the port speeds and anything else that would be relevant and pertinent to include.
Certainly.
This is cool.
I can help you create a more detailed version of your network diagram with the addition of finer details such as port speeds and other relevant information. However, I should note that I cannot physically print out the diagram for you since I can only operate in a digital environment. What I can do is create a digital version of the diagram which you can then download and print out using your own resources. Let's proceed with creating a detailed digital version of your network diagram. Before I start, can you please specify the additional details you want to include in the diagram? Here are some points you might consider. Port speeds E, G, 10 gigabits per second, 40 gigabits per second, 100 gigabits per second for different connections. Types of ports E, G, SFP+, XFP, used in different devices. Cable types E, G, fiber, copper, used for different connections. Redundancy features E, G, link aggregation, redundant power supplies.
A digital version is perfect. That's exactly what I am looking for. Please also include an example of a device that I could purchase for each of the devices in the diagram. I just want to see an example of what a real device would look like that would be appropriate for the role. Now here's where it's like, I feel like this right now is like the it's like when Google was first released before, like, or like YouTube before it was based on watch time. So like oh, no, I don't have a list. Please just make up your own list, and if something is unclear, you can just be more generic with it. So this is where it's like, eventually this is not gonna be as good as it is. It's gonna get worse and worse. And I think the reason is because whenever you ask it a question like this, it's gonna have like ads built in. It's gonna be like, oh, well, you can buy this, and then whoever pays, you're gonna get like a political ad instead of. So I feel like we're at a very special time right now where like this is pure in a way that it won't be like tomorrow. And I think Google was like this when it like was first released. Like it would just show you search results based on our rankings, but now it just shows you advertisements. This is so cool. Look, it's doing it. It's oh come on, don't be cool. Come on, be cool, please. What? Why did it mess up? Well, I mean, the cool thing is like we can see what it was trying to do, so we can see that like the distinctions it made. So it looks like it didn't really make any choices. It didn't include any specifics. Yeah, it's not making any choices because otherwise they would have like another. Oh, that's cool. So you can see like, man, this is going to be powerful in the future because this is all going to work. Like it's going to be able to do it. Like right now it sucks, but like in the future it'll be able to do this. But unfortunately it'll be used for like advertisements and little blue pills that you can take. Like this will just be an advertisement for Viagra. Once it actually has the capability to realize what I'm trying to do, it will try to redirect my attention into something else. All right, so diagram freaking sucks. The diagram doesn't have any details on it at all. Please add them. Yeah, please do that. So again, we can see its work here. So it looks like it's gonna fail to do it. It still doesn't. It still does. Yeah, it's not including any specifics. Maybe. Oh, it's cool. Okay, it's doing it now. Wow, that's so cool. Look, it's doing it. Wow, that's fascinating. Whoa, my mind is like blown. Look, they even have the least line. Oh, it even made that decision. Wow. Wow, this is so cool. Okay, so let's read the decisions it made. So for the core switch, it picked out a Cisco Catalyst 9500. So let's take a look at that. Yeah, so it's a fixed core enterprise network, and it got it right too. That's so cool. Yeah, so here's what the core switch would look like. Okay, and then it's got here's the firewall it picked out. This is so awesome. So the core switch it picked out has QSFP 28 ports. Let's see if we got a Cisco Catalyst 9500. This is so cool. What are these? So this isn't even a catalyst. Do we have one? So here's a Catalyst 800V. Um Now these aren't I don't think these are catalysts. Uh let's look at this cuz this is it's not a 9500 either. what do we got for switches? So this is a catalyst. It looks like NXOS. These are going to be hard to get a hold of the images though. You have to have like a service contract. I think this is. Yeah, you have to order it. Um. All right. Let me pause the video and be right back. All right. Sorry about that. I'm back. So let's keep looking through. So, and I'll open this again. So unfortunately, this is why, as I talked about in my other series, this there you can't like you can't just have these. Like, this is a proprietary thing. So like, that's why I'm going for the LPIC. That's why I want to get my PCAP. I just want to be able to that like pay to play, or like whoever has the most access wins. Like, I want more. I want my efforts to count and not just be based on like whoever has, But you can see they've got these. These are probably the QFP 28s. I don't know. Okay, so then here's our firewall, which is so cool. This is so cool. Let's see if we can get the firewall image. Sometimes it's sometimes you can just get like a demo image or something like that. So firewalls. And sometimes they just come right with the like on there already. So do we have a Palo Alto? Probably not. Shoot. I mean, we have like a FortiGate. Like, I'm sure we have something. What I need is like just a list of these, and then to feed that in there. So Palo Alto isn't going to be under here. This is so cool. Okay, we got nothing. Okay, so let's just keep going here. So I've got the 8 ports there. I'm gonna add some ports to this one. So let's see how many ports are here. So we got 4. Let's add 4 more for a total of 8. All right, and then we're gonna add some here as well. All right. Okay, and then we'll cable them up. We'll add this is the oh yeah, so we got to choose what this is for. If it's for this is just one of these. So yeah, for one of those we don't need a redundant link there. So we'll take care of that. So we're going to delete that, and this is going to be so let's ask the AI. That's so cool. Okay, so I mean we've got different kinds. So one thing I noticed on the original diagram, not the one you made, but the original one I uploaded, is that the access layer has the access layer, ACCESS layer, has multiple blue boxes. It has some of the boxes that connect up to a distribution layer with links in between the distribution layer devices. And then it has some without those links. It also has some with firewalls connecting, and then the public internet, and some connecting to the WAN, and some without. What would you provide as a general label for these boxes? Each of these boxes, what would they be called generally?
In a typical enterprise network diagram, the blue boxes you referred to in the access and core layers would generally represent different network devices or groups of devices that perform specific functions. Based on your description, here are the general labels I would assign to these boxes. Blue boxes in the access layer switches.
Yeah.
These are usually switches that facilitate connectivity for end-user devices such as computers, printers, and phones. They can be labeled as access switches. Blue boxes in the core layer with connections to the distribution layer routers switches. These could represent core routers or switches facilitating the high-speed, high-capacity backbone of the network. They can be labeled as core routers switches. Blue boxes with firewalls connecting to the public internet firewall security appliances. These boxes likely represent firewall or other security appliances that manage traffic between your internal network and the public internet. They can be labeled.
What about the larger blue boxes that each of those smaller blue boxes are encapsulated within? What would each of the larger blue boxes be labeled as?
Larger. Blue boxes that encapsulate smaller blue boxes in network diagram typically represent different network segments or zones within your enterprise network.
Tell me.
Each larger blue box groups together devices that work together to serve a specific role or function in the network. Here are some general labels that could be used to describe these larger blue boxes. LAN segment, local area network. This segment contains access switches and end-user devices such as computers and printers. It represents the local network infrastructure where most of the organization's internal devices are connected.
Okay, this is
Core network.
good.
This is
I
the
love
central part of the
this.
network, containing high-speed, high-capacity routers and switches that facilitate data transfer between different parts of the network. It serves as a backbone connecting various segments of the network. DMZ, demilitarized zone. If there is a segment connected to the internet through a firewall, it could be labeled as the DMZ. This area contains servers and other resources that should be accessible from the public internet, such as web servers and email servers. One segment, wide area network. This segment facilitates connectivity to external networks, including connections to remote offices, cloud resources, and the internet. It contains routers and other devices necessary for WAN connectivity. Data center. If there is a segment containing servers and storage devices, it represents the data center, a centralized repository for storage, management, and dissemination of data and information organized around a particular body of knowledge or pertaining to a particular business. Server farm. In larger organizations, a dedicated segment containing only servers, often referred to as a server farm, can be present. It is a high-capacity segment hosting servers that run applications, store data, and provide services like DNS, DHCP, etc. Services segment. This segment would contain servers and other resources providing network services, such as authentication servers, DNS servers, etc. Remember that these are general labels, and the exact label for each segment would depend on the specific role that segment plays in your network. Would you like to add these labels to the network diagram? Let me know how you would like to proceed.
Okay, so yeah, let's do this. So we're gonna kind of go our own way here, in the style of Fleetwood Mac. Um, and then yeah, we're gonna build out all these different sections. So and then we're gonna say yeah. So and then we're gonna use these labels that the AI made for us. Um, so we've got just a LAN segment. We've got the core network. Yeah. So the thing is, the core network, we should have like its own box for it. So let's just draw like a bigger box and put that in the background. And we'll just draw it down here. Oops, that's not that. How do I just draw a box? I thought there was a way to do that. I mean, I can just duplicate one of these. I thought I could. There we go. I think it's this. I'm not sure. Or you can go. You can go here. I think. I thought it was this, but I don't know why. Oh, it is. It is. Okay, good. Okay, so there we go. Yeah, let's expand this out. There we go. Expand this down. There we go. Send it to the back. Send it all the way to the back. Okay, and now we're gonna have these come out. Okay, and then we're gonna label this campus core. So let's just bring everything out. Okay, so and then let's label that campus, and then we're gonna label this campus core. And then we'll bring one of these boxes back. Okay, so there we go. And now the core will plug into all kinds of different distribution layers. So we definitely want these cores to have a lot of ports on them. So it says that like, and the other thing is I don't think this is a appropriate device for our core. Let's see what else we have. Do we have a catalyst? So we have a nexus. Let's look up a nexus. So we have a nexus 9500V. So what's the difference between a catalyst and a nexus? Yeah, so we have one of these. So this is a So why would you use one for the So these are the catalyst 9500s. Let's take a look at the nexus. Why is it so hard to just Okay, here we go. This isn't Oh, here we go. So here's the nexus. It's like more of a data center. All right, let me ask it this. So regarding the core layer again, what you recommended was a Cisco Catalyst 9000 series device. Now, let's say that I don't have that device, but instead I have a Cisco Nexus 9000 series device. could I just simply use the Nexus instead? What would be the pros and cons of using the Nexus instead of the Catalyst?
Absolutely, you can use a Cisco
Okay.
Nexus 9000 series device in your core layer. Both the Catalyst and Nexus lines are robust and capable, but they are designed with somewhat different focuses and therefore bring different strengths to a network. Here we explore the pros and cons of using Nexus 9000 series instead of the Catalyst 9000 series. Using Cisco Nexus 9000 series Pro's data center focus, the Nexus series is primarily designed for data center environments, providing a range of features
Oh,
optimized for
okay.
data center
So the
networks,
Nexus
including
is
support
just
for
the
automation,
nice one.
virtualization, and software-defined networking (SDN). High-performance Nexus 9000 series switches are known for high performance, supporting high-density 10, 40, and 100 gigabit Ethernet connectivity, meeting the demands of large and complex data center environments. ACI and VXLAN support. Nexus 9000 series supports Cisco's application-centric infrastructure (ACI) and VXLAN, allowing for more efficient and flexible network configuration and management, especially in virtualized environments. Enhanced Security. Nexus 9000 series offers advanced security features, including integration with Cisco's security portfolio, to provide a secure data center environment. Cons. Cost. Nexus series switches tend to be more expensive than Catalyst series switches, potentially increasing
Yeah.
the total cost of your network infrastructure. Complexity. With its focus on data center environments, Nexus 9000 series switches offer a wide range of advanced features, which can increase the complexity of your network configuration and management. Overkill. For small to mid-sized networks. If your network is not particularly large or complex, the advanced features of the Nexus 9000 series might be overkill, providing more capability than you actually need. Using Cisco Catalyst 9000 series Pros enterprise focus. The Catalyst series is designed with enterprise networks in mind, providing a range of features optimized for enterprise environments, including robust support for campus networks and end-user connectivity. Integrated Security. Catalyst 9000 series switches offer integrated security features to help protect your network and data, including encrypted traffic analytics and endpoint security. Ease of management. Catalyst 9000 series switches support Cisco's DNA Center, providing a centralized management console that simplifies network configuration and management, offering an intuitive interface and automation features. Cons. Less focus on data center features. While capable devices, the Catalyst series does not offer the same level of focus on data center features as the Nexus series, potentially lacking some advanced data center capabilities. Potentially lower performance. While still offering high performance, Catalyst 9000 series switches might offer lower performance compared to Nexus 9000 series switches, especially in high-density, high-capacity environments. Conclusion. In conclusion, while you can certainly use a Cisco Nexus 9000 series switch in your core layer, whether it is the best choice depends on your specific network needs and the characteristics of your environment. If your network has a significant data center focus, a Nexus 9000 series switch might be the better choice, offering advanced data center features and high performance. However, if your network is more of a general enterprise network, a Catalyst 9000 series switch might be sufficient, providing a balance of performance, security, and ease of management. It's always best to consider your specific needs when choosing network devices.
Okay. Well, I'm kind of surprised here because this actually costs more. So maybe I've got the wrong. This is a fabric module switch. I don't know if that's. Uh. Oh, okay. So this is kind of more what I'm expecting to see. So here's like a. Yeah. So this has like the image. So yeah, you can see the price difference. I mean, I might be it's a order of magnitude more expensive to use a Nexus than it is to use just a Catalyst. So it'd be nice if we could use the Catalyst image because that would be that's what like makes sense. But I don't really have the Catalyst image. Now these here aren't Nexus images. Where do I have the Nexus? I'm pretty sure I have a Nexus dropped somewhere. Yeah, so here's where my Nexuses are dropped, which I don't think makes sense. I'm not sure. The AI helped me pick this out, so maybe it is good. We also have so we have the Nexus, which is probably good. But the Nexus is overkill. Really, the best choice would be that Catalyst, which is like one of these even. Really, you just need to know what the what the requirements are. So like this Catalyst 800V would be good. Even just like one of those. You just gotta know, are they capable of gig ports, 10 gig ports? You've got to do calculations as well. So like this would be great. This is what I want here, but I guess it's not as easy to get that image. which is unfortunate. But I mean, these are catalysts here. I'm pretty sure I have. Yeah, I have one of those here. I mean, this is what I have dropped. So let me start this and take a look. Oh, are these my nexuses? No, no, these are um and again, these are just images. They're not the actual hardware. So the difference between a Catalyst 9000 or like a 7000 is probably just the hardware and um not the operating system at all. And we can ask the AI about that. Okay, great. So here's another question. When it comes to the difference of platforms, for example, a Catalyst 9000 versus like a Catalyst 7000 or whatever. So like the difference between a switch of the same type, a Catalyst or the network, or sorry, I mean the Nexus, does that mean that there are cases where the operating systems are exactly the same and it's just the hardware form factor and capabilities that is different between, for example, a 7000 or a 9000? Or will they also have different operating systems?
The different series in Cisco's Catalyst and Nexus lines not only come with different hardware capabilities, but often operate with different versions or entirely different
Okay.
operating systems.
Yes.
Let's delve into the details. Cisco Catalyst Series Catalyst 9000 Series Operating System. Cisco iOS XE features. This series is designed to be more programmable and to work well in a software-defined networking environment. It supports a variety of modern features such as model-driven programmability, streaming telemetry, containerization, etc. Catalyst 7000 Series Operating System. Cisco NXOS 7000 Series or iOS XR 7600 Series features. These series have a legacy in providing robust solutions for large enterprise networks and service providers, offering high availability, a wide range of interfaces, and high throughput. Cisco Nexus Series Nexus 9000 Series Operating System. Cisco NXOS or ACI mode for software-defined networking features. These switches are designed with data centers in mind, providing high performance, a range of virtualization features, and the ability to work well in a software-defined networking environment. Nexus 7000 Series Operating System. Cisco NXOS features. Like the 9000 series, these switches are designed for data centers offering high availability, high throughput, and a variety of advanced features. Comparison and considerations operating system Cisco IOC, a more modern iteration of the classic iOS, used in the newer Catalyst series to provide more advanced features. Cisco NXOS, a data center-focused operating system used in both Nexus and some Catalyst series. Cisco iOS XR.
Okay, yeah, so it just depends. While there is a hardware difference between different series of the same line, they also come with different operating systems. So, all right. But I mean, I think this is fine. It's really just about what kind of ports you have. Now, we have 1 gig ports only, which probably isn't enough. Yeah, 1 gig ports probably aren't enough for this. Um, so let's take a look at the distribution. Really, it's about the ports. I'd really like to get just a list of. Let me try to do that. So we'll do like a lab, and then we'll just try to get a list of all the images I have. So CD GNS3 images, CD iOS. We can do like a tree. There we go. Yeah, so here's all the images I have. Yeah, and these are the ones I actually have, not just the ones available. So this is perfect. So let's feed that into the AI. please redraw the diagram that you made earlier. That was absolutely perfect. But here are the image files that I have to use. Please redraw it using the most appropriate image file that I actually have. Here is the list. Actually, sorry, just ask me for the list and then I will provide it. And then once I provide it, draw the diagram.
Absolutely. I'd be glad to help with that. Please provide me with the list of image files that you have, and I will proceed to redraw the diagram using the most appropriate images from the ones you provide. Thank you for providing the list of image files. To redraw the diagram, I will need to know which image files to use for each component in the diagram. Based on our previous discussion, the components include core switch, firewall, distribution switch, access switch, router, WAN, data center. Could you please specify which image file corresponds to each component? If there are multiple options for a component, let me know your preference.
Well,
Once
I
I have
mean,
this information, I can proceed with redrawing the
that's what
diagram
I
using the
need.
images you provided.
That's what I need your help for. I need your help to determine which image file needs to correspond to each component. I need help making these decisions, please.
Absolutely. I can help suggest which image files might correspond to each of the components in your network diagram. Here are my suggestions based on the typical functionalities of these components and the image files you have.
This is so cool.
Components and corresponding image files. Core switch, suggested image file. Nexus 950OV. 9.3.3. QCOW reason. Given our discussion about possibly using a Cisco Nexus 9000 series device for the core layer, this image file seems like a suitable representation.
Yeah.
Firewall suggested image file. FGD_VM64_KVMV5 build 0742 Fortinet. Out. KVM. QCOW reason. This file seems to represent a Fortinet firewall, which would be suitable for the firewall component in your network. Distribution switch suggested image file. VOS LAB4. 25. 0F. VMDK reason. This file appears to represent an Arista VOS lab switch, which could be used as a distribution switch in your network. Access switch suggested image file. Aruba OSCX disk image generic x86 P420,210,316,185,909. VMDK reason. Given that this file seems to represent an Aruba OSCX disk image, it could potentially be used to represent an Aruba access switch in your network. Router suggested image file. Bias of vendor Private M. VMDK. SPA. 156 to do. T. QCOW reason. This file appears to represent a Cisco iOS router image, which would be suitable for represent.
Yes, please create the diagram. Period. I hope I didn't confuse it by saying period. Looks like I didn't. This is so cool. Look at that. It's picking it out. Now, I don't know why it's got this one here, but hopefully we'll see on the diagram. And it's including the links as well, which is really cool. This is so cool.
It seems there was an issue with the code execution
Aw,
environment.
come on.
Let's try to redraw the diagram. Before proceeding, I want to clarify that while I can associate each component with the most appropriate image file from the list, the actual image files are not visualizable content but rather virtual machine or disk images used in virtualized environments. Due to this, I won't be able to use these files as visual representations in the diagram. However, I can proceed to create a network diagram using generic icons that represent each component based on our discussion. Would you like to proceed with this approach?
I wonder if I could feed it my own icons. That would be so cool. I mean, I could just take the code and do it myself. I can have it walk me through how to use this code and then just do whatever I want. Yeah, it just doesn't have images to use, so I need to tell it to pick out its own images. So we should see that in the... We should see an extra... So we got the labels. Yeah, it doesn't know.
It seems there was an error because the necessary libraries were not imported.
Oh.
Let me correct this and try to create the diagram again.
Yeah.
Let's proceed with this.
It doesn't have a library. So up here, oh, it didn't include it. There we go. Okay, so yeah, there we go. Cool. So here's the
Here's the redrawn
diagram.
network diagram with generic
Yeah.
icons representing each component.
Yeah, so it's got generic icons. Okay, so now it has. Oh, this is out to my least line. So okay, so it's got this is probably like my DMZ. Oh, this is these out to my least line. That's so cool. Yeah, so I guess you only need like a gig out to the least line. Then we need our Fortinets, which is like a 40 gig, yeah, out to the internet. I don't know what the WAN is for. Um, Tell me what the WAN is for. I would have thought that it was for access to the data center or even access out to the internet, but I see that we have those separately. Yeah,
Architectures, the
what
wide
is
area
this
network, WAN,
for?
typically refers to the broader network that connects multiple local area networks, LANs, together. It's used to transmit data over long distances, potentially connecting networks across cities, states, or even countries. Let's delve into how the WAN in your diagram interacts with other components and what its primary functions are. Primary functions of WAN connecting
Okay.
remote branches, inter-branch communication. Enables seamless communication between different branches or locations of an
Why is
organization.
the link?
Resource sharing. Allows for the sharing of resources and data between different geographical locations. Remote access to the data center data transmission. Facilitates the transfer of data between the data center and remote locations or individual users.
So like a
Backup and
redundant
recovery.
link?
Can be used to back up data to a remote data center for recovery in case of emergencies. Internet access connectivity. While the diagram shows separate connections to the internet and the WAN and many networks,
Why does it only need 1 gig? I would think that it would have to be a giant 100 gig or so connection in order for access to services, interactions with other components, or even just security traffic to be processed effectively.
here.
Oh,
Absolutely right that in many modern enterprise
yeah.
environments, a 1 gigabit per second connection for the WAN might be insufficient, especially for large organizations with substantial data needs and multiple remote locations. Let's discuss why a higher bandwidth for the WAN might be necessary and what it entails. Increasing the WAN bandwidth, high volume data transfers, data center access. Facilitating faster access to the data center resources and applications, especially for remote users and branch offices. Cloud services real-time access. Ensuring seamless and real-time access to cloud services and applications, which often require substantial bandwidth. Internet connectivity, high-speed internet, supporting high-speed internet access for all users in the organization, especially when there are simultaneous accesses to bandwidth-intensive services such as video streaming. Bandwidth considerations cost higher expenses. Increasing the bandwidth to 100 gigabits per second or similar high-speed connections will significantly raise the costs, both for installation and ongoing service fees. Infrastructure hardware compatibility. The existing network hardware, including routers and switches, must support the increased bandwidth. Fiber optic cables. High-speed connections often require fiber optic cabling, which can be expensive to install if not already present. Redundancy and reliability. Redundancy. Higher bandwidth allows for better redundancy, ensuring network availability even if a part of the network fails. Load
Yeah,
balancing.
yeah,
To
update
facilitate
the
more effective load
diagram.
balancing, distributing network traffic efficiently across several paths. Security traffic monitoring. Higher bandwidth enables more effective traffic monitoring and security measures as it prevents.
Yes, please update the diagram. Now the cool thing is like if I can get this library to work. Oh, and they didn't include the import statement, so this is going to fail. But like if I could just like do this myself. Just as long as I have those libraries working. Which I mean it's just like MATLAB. It should be pretty easy to install. Oh, it worked without importing it somehow.
Here's the updated network diagram with the WAN bandwidth increased to.
Maybe because it's already been. Okay, so they put a QSFP28 in this, but they're still just using Cisco iOS. I don't think I can do that. Um, that sucks. Um, okay, but the fact remains, I don't think these core switches can be just these catalysts. They're just not beefy enough. So the core layer would be these Nexus 9000s like that. That makes the most sense for the core layer. So I'm gonna delete these. And you know what? We're gonna go our own way anyways. So like, we just want to make the best decisions. Let's just get everything. And then we want a there we go. We want a Nexus 9000 for the core. There we go. And then we want 2 devices in the core. So we're going to change the host name. Core is 01. And then duplicate. All right, and we're going to name it core 02. All right, so that looks good to me. So yeah, let's just move it over here. And I'll put the label outside to make it more consistent. Okay, I can shrink this like that. All right, let's see how many ports these come with. That'll give us a sense. Okay, so they come with 10, which is better than 4. Now we can see they're 1 gig. Can we beef this up somehow? So these are like the modules. Oops. Shoot, we only get 1 gig still? That's not gonna work. Oh, that's seriously all we get? I don't think that's gonna work. It's no better than the other ones. We need something. We just need like beefy ports. Yeah, we need 100 gig fiber ports that support QSFPs. Man, really? Yeah, E1000 Ethernet. That means it's just 1,000 megabits. We need it to be 10,000 megabits. I mean, maybe we can get a custom adapter. No, because we still have the same options. Yeah, it's just a 1 gig just like the other one. Well, shoot. It looks like my Nexus 9000 core switch is only capable of 1 gig. Does this still make sense to use? Are there any other switches that are capable of a higher link speed based on the image list that I posted earlier? Yeah, I gotta get
Based on
beefy.
The list of image files you provided earlier, we can identify a few potential options for your core switch that might support higher link speeds. First, VIOS, Virtual Extensible Operating System, image files.
So this is better to
VIOS
use,
LAB4,
right?
25, 0F, VMDK details. Arista VIOS is the virtualized version of Arista ZIOS software. The latest Arista switches can support link speeds up to 400 gigabits per second, but the exact capabilities might be different for the.
Yeah, but like, it's saying that like, yeah, like the Nexus 9500 like makes a lot of sense, but like it looks like my particular Maybe it's just like the way mine's configured, but um, it's just like these. I don't have the ability. Like maybe if I swap it out like this, but the thing is like I don't know where these are. Let me try to find the list of those on the lab. So what we got? We got a I 82801. Let's try to find that. So we're gonna do find I 82801. Uh, uh, or dash name. Dash name. Oh, unknown predicate. We gotta quote it. Nothing yet. I just wanna take this list as text and feed it into the AI. Uh I probably need a sudo for this, but no, it's fine. Uh Let me try it again with the sudo. Then I won't get as many permission denieds. Man, this is rough. I can't have these 1 gig. Like that's the thing that really matters. Um all right, so let's try the Arista. Or actually we can just go to configure network. Yeah, this is what really matters. Now we can see we've got this adapter that's selected by default. So maybe we can just select that for some of the other devices. But it might be a what's a Realtek 8139. Realtek 8139. Yeah, so it's a fast Ethernet controller, but I don't know like if it's so this is like a can we see a picture of it? Yeah, it's a network interface card. But it's like it's not it doesn't look like that. I don't think. Or it won't have like all this extra metal on it. You know, it's just part of the device. So that's the AI. Because that's the thing is like I'm sure any of these are fine, but we gotta plug in the right adapter into it. Like we have to load it up, and it looks like all we can load it up with is uh 1 gigs, and we need to load it up with like 10, 40, 100, 400. Like we can't let me quit out of that. So, man, I have haven't used these in a while. I just want to see like show ports statistics. Oh, maybe transceiver. And then you have to feed it one information. Okay, so it's, I just want to see like, I don't want to see the description. I want to see like the actual details. Yeah, like the information. There we go. I want to see like the show prots. I want to see like the oh, I guess I could just see everything. I'll do that. Oh, I have to filter it. That's not it. I just want to see like what they're capable of. Um, I feel like statistics is a good one. Transceiver would be great, but let's try that. Nope. Man. I mean, what if we go configure I remember this. Configure, yeah, and it's like configure ports and then like port 1. Oh, right. It's like there's a lot of, it's like being on one. It's like the one all on one line. So how do we get the, so there's auto negotiation. How can I set like the link speed? Oh, let's try to enable DDMI. Okay. Let's do it. Let's enable DDMI for, or let's do a, now we've got the show ports. Transceiver. Now we can do that. Information. So yeah, it's, even though it's on, it's still not supported, and I don't think this would show us. You know, this is like dependent on, like you can't simulate this. Like it's actually, you can't simulate, or you can't simulate that. Shoot, this is so bad. How do I remember like there being like, it being like kind of frustrating sometimes. So it's like show ports link scan 1. That's it. Configure ports link scan. Oh, interval. Yeah, I can't. I mean, I guess I could ask the AI. How can I determine on each of the switches what the max link speed the ports are capable of? What commands can I use at the CLI to help me determine this? And
To
we're
determine the
we're at
maximum
the 3 hour mark now,
link
2 hour.
speed that the ports on your switches are capable of, you can use various CLI command line interface commands based on the switch operating system. Here, I will outline the commands for some of the most common switch operating systems. Cisco IOS for Cisco switches running iOS, you can use the following command to view the interface status and details including the speed. You can also use the following command to get detailed information about a specific interface. Cisco Nexus OS for Cisco Nexus switches, the command to show interface details including the speed would be. For SDEOS for switches running or SDEOS, you can use the following command to see the speed of the interfaces. Juniper Junos for Juniper switches, you would use the following command to see details about the interfaces, including speed. Extreme Networks Exos for Extreme Network switches running Exos, you can view interface details using General Node Specific Interface. Replace Gigabit Ethernet 0/1, Ethernet 1/1, etc. with the specific interface identifier on your switch. Documentation. Refer to the official documentation of the specific switch OS for any variations in the commands. Interface configuration. Sometimes the interfaces are configurable and the speed can be set manually using configuration commands. Auto negotiation. Modern switches usually have auto negotiation enabled, which allows them to automatically determine the best speed in duplex mode. Remember to access the CLI with the necessary privileges to execute these commands. Once you've identified the maximum speed capabilities of your switches, you can plan your network accordingly to ensure optimal performance. I hope this is helpful. Let me know if you have further questions or details to add.
It's not. I can't see anything. Um. Oh, and these nexuses are like difficult because they're basically like just like Linux machines. Like they're more like just a basic like Linux box than they are like a router until you like boot it up. 15 minutes. You cannot wait that long. Okay, so then let's look at the. I feel like the Juniper should be good for the core. So here's a data plane. Here's a control plane. I feel like this is the best choice. Why not choose the Juniper VMX image for the core?
Choosing the Gen. Juniper VMX image for the core of your network is indeed a viable option. Let's discuss the pros and cons of using Juniper VMX as the core switch. Pros of using Juniper VMX High Performance Virtual Router Performance. Juniper VMX is a high-performance virtual router that is designed to support advanced routing features, making it suitable for core network deployment. Advanced features. It supports a wide range of advanced Juniper features, which can be beneficial in a core network setup to ensure optimal routing and network efficiency. Scalable. The Juniper VMX router is scalable, allowing you to adjust its performance based on your network commands, which can be a significant advantage in a growing network. Support speeds high-speed links. The Juniper VMX router can support high-speed links, potentially up to 100 gigabits per second and beyond, which will align well with your high-speed WAN link. Cons of using Juniper VMX.
What about So I'm trying to simulate this in GNS 3 using QUEMU, QMO VM, QEMU, QEMU. I'm trying to simulate it using virtual machines. And under the network tab, where I can choose the number of adapters, there's an adapter type setting, and it's set to Intel Gigabit Ethernet E1000, INTEL, Intel. And it does that mean that I'm only capable of 1 gig? Is there something else I can set it to that is capable of more than 1 gig?
NG. NS3 when you are using QEMU VMs, KVM, QEMU, you indeed have options for setting different types of network adapters, including the type that you mentioned, Intel E1000. The adapter type can influence the maximum throughput of the network interfaces in your virtual machines. Here's how you can address your concerns. Network adapter types in QEMU, KVM Intel E1000 default setting, often the default setting in many environments, supporting up to 1 gigabit per second. For TO optimized performance. An optimized, paravirtualized network driver designed to be more efficient than emulated hardware drivers like E1000.
All right, so
High
I
speeds.
I gotta use this
Vertio can
one.
technically support speeds much higher than 1 gigabit per second and is generally recommended for better performance in virtualized environments. Realtek 8139 legacy hardware. As
I gotta
discussed earlier, this is a
use
more legacy option, generally
Vertio.
supporting speeds up to 100 megabits per second. Changing the network adapter type to change the network adapter type in GNS3 to potentially support higher speeds.
I
Go
gotta
to
use this one.
QEMU VM settings network tab adapter type. Here, you would select the preferred adapter type, such as Vertio Net PCI to leverage the Vertio per virtualized network driver. Number of adapters. Specify the number of network adapters you wish to have. Testing network throughput after setting up your VM with the preferred network adapter type, you would want to test the actual network throughput to verify if you are getting the desired performance. IBER 3. You can use tools like IBER 3 to test the network throughput between different VMs in your GNS3 environment. Monitoring tools. Utilize network monitoring tools to observe the real-time performance of your network. Note host system support. Ensure your host system supports the selected network adapter type. GNS3 version. Ensure you are using a
All right, so there we go. Okay, so let's see what we got for this one now. So this is Ethernet 101. Aha! So there we go. So now we've got it capable of 10 gig on this. That's good. Um, that's probably enough because we can simulate, a network from the 90s that has like 100 gig at the access layer. Probably if we have the 10 gig, it'd be nicer if we had like 40 gig or 100 gig or something like that. Let's take a look at some of these other devices, see what we got. And you know what? Before we do that, let's look at this Core 2 that hasn't been configured to use virtualized, and let's see if there's a difference. Oh, this is so ridiculous. That's the thing with virtualization. Like, you really need real hands-on experience. It's just confusing what is what unless you really see it on the job in the wild. Oh, something is going on. Let me take a quick break. I'll be right back. All right, I'm back. We're at the 2 hour mark. That's pretty long. I might split this up. I want to keep going on this because this has been really fun for me. This is how I have fun. So let's see the difference between the link capabilities of a Vertio, I think it was called. Yeah, a Vertio and a Intel E1000. So this one is set for a Intel E1000. We can see that here. So if I do right click, configure network, we've got an Intel E1000. And if I right click here to configure network, we've got a Vertio. So let's see if there is a difference. Oh, let me pause it quick. I'll be right back. All right, I'm back. I kind of got distracted doing other things. I don't know. I'm just kind of done with this. So, yeah. So. Oh, right. I was waiting for this to come up. Is it? It's Saturday, right? Yeah. Oh, and this takes a long time. Shoot, I wish this would not take so long. Oh, and it's got a timeout. Oh, this is the extreme. All right, so this is the one that matters. Okay, so we gotta wait for the other Nexus. Yeah, the Nexus are a decent choice. Probably the best choice so far because we've got that 10 gig. We do have other choices to make. This channel's all about making good choices. So what if we switch this one? So this one's para-virtualized as well. Let's try booting this one up. Alright, and then we've got like all these. These are the Nexuses, so that's the same. The Nexuses I was using for my distribution. So here's a Cumulus Linux box. I wonder what these have. Let's start up one of these. The thing is, like, you don't need Edge. Well, I don't know. I don't know what's going on. Okay, here we go. This is finally up. Alright, so let's see what the difference is now. We can get some sort of clarity here. So yep, we've got a 10 gig there. Okay, so it's kind of the same. It didn't matter to change that. What happens if we go configure terminal interface Ethernet 1-1? We do link. We do speed. Yeah. Okay, so even here, you know, we've got this speed. Let me ask the AI something. So why is it that you can select but in the earlier command output it says does this mean that even if I select I will only get max?
In the context of your output and the available configurations in the CLI, the hardware capabilities of the Ethernet interface are indicated as supporting speeds of 100 megabits per second, 1 gigabit per second, and 10 gigabits per second.
Yeah, that's what I thought.
These are the physical hardware limitations of the port, and they cannot be exceeded.
Right.
However, in the configuration mode, the switch is presenting options to configure the port at speeds up to 400 gigabits per second. This discrepancy is likely because the software on the switch supports configurations up to 400 gigabits per second, but the physical hardware of this specific port on this specific switch does not support those speeds.
Yeah, so we only got 10.
Hardware limit. The real limit is what the hardware supports, which in this case is up to 10 gigabits per second. Even if you configure a higher speed, the hardware won't support it, and it will not function at speeds higher than 10 gigabits per second. Software capability. The software can support a wide range of speeds because it is designed to be used with a variety of
I wish I could get the because when I right click it and I go to configure, I get this whole list. So I guess I could do an OCR. Let me do an OCR analysis of the list. So open the list. I'll do Control N or print screen. There we go. Oops, but I can't have the list there, so I'll put it down here. I'll do print screen. There we go. Okay. So use CR to write out the text shown in the uploaded image. and I gotta save it. Or did I save it already? Nope, I gotta save it. Okay. I can do that. Why did it it looks like when I did that it just disappeared. It's like it doesn't actually take a screenshot. It just like shows up and then goes away. Yeah, so it just when I actually do it like that, it just shows up and goes away. It doesn't actually take a screenshot. Yeah, it says that this will do it, but that's not the case. Yeah, and then I can't do it with that open. So the only way is to hit this print screen, but when I hit the print screen, it doesn't actually. What does this do? Window mode? Oh, yeah, give me that. See, it doesn't do anything with it. Like this would be what I want. Yeah, like this would be what I want, but it doesn't work. Yeah, like this is it. It's just I can't actually, like, I click on it and then it just goes away. Is that because it's in? What if I go to paint and then do a control? Okay, there we go. That's fine. Okay, there we go. All right, try it again. Oh, sweet, it did it. That's cool. I like that. Yes, so in that list of different network adapter types and their corresponding driver identifiers, is there something I can choose from that list that would allow that Nexus output that I showed earlier to have a link speed that isn't hard limited at 10,000, but instead where I could use one of those software options, for instance, of the 40,000, because the physical limitation has been increased by selecting a different network adapter type and its corresponding driver identifier?
Absolutely. Selecting a different network adapter
Which
type
one?
may allow you to potentially increase the maximum link speed in your virtualized environment, bypassing the physical limitations of your current hardware setup.
Oh, really?
From the list extracted from your uploaded image, the following network adapter types and their corresponding identifiers stand out as potentially allowing for higher speeds. Intel PCIe Gigabit Ethernet E1000E, while it's prefixed with gigabit, PCIe interfaces can potentially support much higher speeds, including 10 gigabits per second, 40 gigabits per second, or even 100 gigabits per second depending on the specific implementation. You would need to refer to the documentation or technical details for the specific Intel PCIe Gigabit Ethernet adapter type you're looking at to confirm the maximum supported speeds. VMware Paravirtualized Ethernet v3, VMX 3. This is a virtual network adapter developed by VMware that is optimized for performance in a virtual machine.
All right. So one thing we can try as well is we're just looking at it for this one port. Sometimes the ports like at the end have more speed. So let's just look at the other ports. So there's two. I think there's 10 ports on it. 5, 6, 7. I mean, even that 10,000 is fine. And it's, it's virtualization. Oh, it looks like oh, wow, I have a lot of ports. I have 64 ports. Oh, well, we can just see it right here. So yeah, it's only capable of 10. It's only capable of 10. Let's try changing one. Figure terminal. 64. Speed. We'll change it to... Let's change it to the full 400. Yeah, see, so the transceiver doesn't support the speed. Yeah, it only supports 10. Which is fine. It's just not perfect. And we can see, these Nexuses are overkill. 64 ports, we don't need that. The Catalyst will probably have a lot fewer ports than that. And then, your heating, your CPU, like cooling, like power requirements, all that goes up. So really, the goal is to buy the goal is to keep a budget and stay in that budget. You don't get anything extra for just having spent more than you need. Maybe if you're going to have a lot of expansion later on, but by the time you expand, if it's years from now, they'll have like new devices, like the CCNP, as we saw earlier, changed overnight, and it's all like MPLS, and it's all gone to like SD-WAN. So it's like everything's gonna just totally change overnight anyway. So there's no sense in planning for like scalability within a few years, because within a few years, literally everything's gonna be different. So just plan for the here and now, and keep that budget and stay within that budget. And and if the here and now is growth of this percent, then you gotta plan for that. I'm not saying to just have a fixed network size based on the average traffic that you have, based on the traffic counts today. I'm saying, have good monitoring in place and take a look at the trends of your internet traffic over time. If it's increasing by 50% a year, and you've got a 10 port switch, buy a 15 port switch, or even a 20 port switch, but don't buy a 64%. a 48 port, you might have some justification for that. It's like, yeah, so, and really that's ports. That's different than speeds. So it gets complicated. It's not easy. So yeah, the 10 is gonna be fine. I think that's really the best we have to work with. Let me ask the AI some more. So 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 okay. Is there something I can choose? So name one network adapter type that I can select from that list that will potentially have the capability for ports of a speed larger than 10,000.
From a list
Yeah.
you provided, selecting the VMware Virtualized Ethernet v3 VMX Net3
Okay.
network adapter type would be your best bet. This adapter is optimized for virtual environments and can potentially support speeds higher than 10 gigabits per second,
All
going up to
right.
40 gigabits per second or possibly even higher, depending on various factors including the configuration of your virtual environment and the capabilities of the underlying physical hardware. It is
Yeah,
designed to provide high performance and to support advanced features available in modern networking hardware.
we tried that. So here I've got I've got the virtualized, and then here I've got the non-virtualized. So if we open them side by side, uh, and then we try changing the speed on both of them. So this is the virtualized on the left. So we're gonna do interface eth 101, and then we're gonna do speed. There we go. Yeah, so it still doesn't the port still doesn't support that speed. Now we can go through and try selecting the other ports just through trial and error. See, this is the one with the E1000. I mean, really, it's going to be honest with you. Like that output we saw earlier is good honest output. Show if we do a show interface, even just the show interface description, we can see the well that doesn't show the capability, but if we do a show interface, now we can see the hardware. So it's good honest output. So let's try a few of those adapters though, and see if we can get hardware that makes more sense. Let's do this. So these we tested two of them. Let's just drop a bunch of them and then try different hardware. So these are the Nexus. Yeah, these are these. So let's try a bunch of these. Let's try just 6 of them for now. There's a lot to try. And it might be possible to like configure the transceiver. So like to set the transceiver. I know that there's like a service unsupported transceiver or something. It's like a secret command. So we still have that limitation there. Uh, so there's like there should be like sometimes there's like a SFP command on there. I don't see it. Or like a switch, maybe. Well, switch port means to convert it to layer 2. Uh, power probably is Oh, okay, that makes it energy efficient. Um, man, this is rough. Uh, I guess link could be it. No. I thought there was something I could do to like change the port type to like a SFP plus or like because SFP and SFP plus are the same form factor. But I don't think that's the case. I think it just detects what you got in there automatically. So like, yeah, okay. All right, so let's close that. We can stop everything just to make sure we don't have too many things running. And then now let's go and configure these. So we'll just select some ones we haven't selected before. So yeah, that looks good. And then configure this to this next one here. Okay. Now this is an interesting one. Let's try this one as well. I kind of doubt that one will work, but okay, there's a bunch of these as well. I have a feeling one of these are the golden one. I have a feeling that some of these will be fine. Let's go with the ER because that's kind of the big one. It looks like the numbers are kind of. This looks like an NE. That might be like a Nexus one. Let's drop one more and then try that NE. Yeah, so this is a Ethernet NE 2K. I kind of also want to try this one because that might be the most powerful one. So they might be in order of power. So let's try that one as well, and then let's boot up all of these. And I really have to stop the video. It's just going on way too long. Okay. All right, so there we go. If one of these turn out to be over 10 gig, I think that'll be a good stopping point for the video. Oops, it looks like I started every single device. I did not mean to do that. That's gonna really slow things down. Okay, so it looks like we've actually got some. I think what's going on here, and let's stop everything. Hopefully, that will be fine. Okay, there we go. And I have a feeling some of those error messages, or yeah, we can see it right here. Device, it doesn't fit in the device, so like it's not gonna work. So if we do a start on all these, we should see that error message one more time. Yeah, so there's some of these that don't fit in the device. So like I wish I could see which one. I wish I could see like the host name I gave it. Um, we got the MAC address, and we got a -3 on there. So okay, yeah. So we do see the host name. It's the -3. So this one, the transceiver didn't actually fit in the device. Yeah, so that one we know isn't correct. So I'll delete this one. All right, but the rest of them seem to be fine. So yeah, now they're gonna take a little bit to boot up, but that's okay. Alright, I'll just open all of these because eventually it should be good. Yeah, see how it runs on BSD? It's like Juniper was really ahead of their time with software. So like a lot of the decisions made by Juniper like are now made by other vendors. Alright, hopefully I can stop this video soon. This is just going on way too long. Oh no, so we've got this as a problem now. Which is weird because it was working before. All right, so I guess what we can do is just get rid of all these because they're not starting up. Let's take a look at uh the server summary. So we're doing pretty good. That's interesting that the RAM is fuller than the CPU. Usually it's the other way around. So this one's rebooting. I think these two are probably in good health. This one went back to the bootloader. Okay. Let me boot up these two. Because those two were working. And I think you can swap out the transceivers with it still running. Oh, okay, so this should be... Oh, shoot, it's at the bootloader again. I don't know why that happens. Because sometimes it's not always at the bootloader. Like, it was fine before. It's almost like I can only have two up at a time. So waiting for system online status before starting POAP. Okay, so system ready. Yeah, okay. So yeah, there's almost like some weird thing where I can only have it be two at a time. But that should be fine. Okay, so looks good. So, yep, box is in stable state. That sounds good. Yeah, this is just way too long. Oh, we're at the 2:30 mark. It's ridiculous. There's a lot of great stuff covered, though. I'm pretty happy with what I did so far, even though not really getting anywhere. Okay, so there we go. So show interface Ethernet 1-1. Okay, so this is the ticket here. Oh, show interface Ethernet 1-1. Okay, so we've got the 1000. So let's try changing it. We should be able to do that while it's up, hopefully. So we're gonna try these two now. And we'll not try the other one. Okay, so what we got now? Now we've got the 100. I don't know if we need to reboot it. So I guess we could try rebooting one of them. Let's try rebooting this one, whichever one it is. So reboot. Like system. I love how Python is on these. Shutdown maybe. Isn't that cool? Python's right on the box. Let's see here. So I guess we could try a exit. No. Maybe like system restart, something like that. Reload, that might be it. There we go. Yeah, that's it. Yeah. With unsafe configuration, that's fine. Okay, so we'll see if the link speed has changed. I'm not sure which one that is. Oh, so that's the 2. So this is the 1. So let's just try changing them. Change it to this one. Same thing. So we'll try a reload on this one as well. It's going to take a while for it to reload, which is really unfortunate. I mean, the 10 are fine. It'd just be nice to have like a 40 or a 100. 100 would be great, but even a 40 is totally fine. Oh, and now we're at the bootloader, so some kind of issue with it, with failing. So let's ask the AI about this. So how can I fix this?
B. Output you provided shows that the system is encountering errors during the boot process and is unable to find the correct boot files to proceed. This suggests corruption or misconfiguration in the boot setup. Here's how you can approach fixing this. Step 1. Identify the problem sysdine checksum failed. It indicates that the system configuration files might be corrupted. No BIOS info found. The BIOS information is not retrievable, which might point to a more severe system issue. Failed to load IPXE and FE shell. The system is unable to load the necessary boot files from the specified locations. Step 2. Potential solution 1. Check the boot files and inspect the boot files. Check that all necessary boot files are present and not corrupted. Reinstall or repair boot files. If
Oh man, that's annoying. Shoot, that's really annoying. I mean, I guess I could just try restarting it like this. Reload, and then I can try stopping this one. and then starting this one. I really need to get away from this. I mean, if the virtualized one doesn't have larger link speeds, I'm not sure why I expect the other ones to. Nope, that didn't work. But that was just the reboot. That wasn't completely turning it off and turning it back on again. But this was the reboot as well. So, yes, please give me guidance for how to complete these tasks, these steps.
Absolutely. Let's break down each solution step by step. Solution 1. Check the boot files. 1. Inspect the boot files. Access the system. Log into your system through a recovery console or a live CD, USB. Locate the boot files. Navigate to the boot.
The boot files are messed up. Yeah, I don't know why that happens. That happens sometimes. The 10 gig will be fine. The 10 gig will be fine, I think. I mean, these are E100s. This is not going to have it. Part of the reason why it's failing might be because of the so let me try changing it back to the default or to the virtualized. Virtualized. And see if that fixes it. So now I can boot up. And I'll try changing this one back to the default, which is this one. So we saw before that the default and the virtualized settings work, but it could be that it's refusing to boot up because the other ones don't work. No, that's a problem. Wonder if it's like a Juniper where you need where the control plane is different than the routing plane and you need another device. Uh I got nothing now. It's just hanging. I don't think it's even trying to reboot it because we're on the console line, so we'd see it. Okay, I think I'm gonna end the video here, and those those 1 gigs I think will be fine. Um, I wish there was something that had more capability. Um, but I got nothing. So, um, yeah. So I think that's gonna be it for this video. Didn't really get that far in the reading. We got down to the gathering information parts. So, we'll take another look at these. Now they're just hanging. Okay, yeah, so that's it. Thanks for watching. See you in the next one. We're going to go with the 10 gigs for the lab.